Good. I'm going to start the webinar. Oh, okay. Webinar.
Hi everyone, we will wait a couple of minutes, then we can start our event. We'll wait one more minute and we can get started. Yeah, I think we can get started. It's almost 5 2. Yeah, hi everyone. Good evening. A very warm welcome to you all to this our Geek Night event. So let me introduce myself first. Myself Kirti. I'm working as an application developer in ThoughtWorks. So once again, welcome you all, and we appreciate you for joining us today for our Geek Night event. So Geek Night is an event where geeks comes together to share, discuss, and learn the technologies together. And this is fully organized and sponsored by ThoughtWorks. So let's get started. Let's quickly go through the agenda for today. So we have a very two interesting topic, which is one is journey from Web 2.0 to Web 3.0 by Kumarji and Razin. and then another, which is followed by another event, which is about Solana, a steps towards sustainable blockchain by Tanvi Nahari and Kamal Lakshmi. So this is our agenda for today, and it's very interesting topic. And before we start, we can just I can just walk you through the ground rules, so that we can make this event more communicative and effective. First one is raise hand. So if you have any doubts or if you have to talk with our speakers, please feel free to use the raise hand option in our Zoom, so that we will allow you to unmute yourself and you can talk with our speakers. And another option is Q&A session. So if you have any doubts or anything you want to share, please feel free to post it in the Q&A session, so that we can take it up, and our speakers will try to answer you. And the last one is survey. So after the event, we will be forwarding a survey form, so that you can give your feedback about our event and speaker and the organizers in the survey form. Yeah, so welcome you again. Without much delay, we have Kumarji and Razin to talk about the journey from Web 2.0 to 3.0. So over to you, Kumarji and Razin. Let me stop share.
Okay, until Kumar is sharing, I'll start with high-level introduction about me. So as you can see, my name is Razin, and I'm working in ThoughtWorks for more than 5 years, coming from a developer background, but right now I'm doing a project/program manager. I'm working in one of the program called as Innovation Lab, where we're trying to work on emerging technologies and trying to solve some of the emerging tech problems. Yeah, mostly about it. I'm from Ahmedabad, Gujarat. Yeah, we'll hand it over to Kumarji for his introduction.
Hello all. Hi, my name is Kumar. So I've been in ThoughtWorks for quite some time, for more than a decade. I've worked with pretty much a lot of technologies, front end, back end, all of that. And right now I play this role of an office tech principal for one of our Bangalore offices, where I look into things like recruitment, producing artifacts such as the tech radar, working with communities and all of that. So it's a semi-technical role, and it's definitely positively challenging me in good ways. So without much further ado, we'll just get started. The first talk for the evening is actually going to be a journey from Web 2 to Web 3. And we hope that this piques some interest in a lot of you if you are unfamiliar with Web3, and even if you're familiar with Web3, maybe we hope that we'll provide it an interesting twist. So let me get started. And the premise for this whole talk, right, is to help you to understand what Web3 is about and why it's important, and a little bit of the how part. So we won't be going into code samples and all of that, but again, we hope to maybe draw some parallels with the kind of development that most of us are used to, which is what we call as Web 2. And maybe in that way we'll try to dispel some of the commonly asked questions. So before we go to Web 2, right, let's quickly understand a very important underpinning of Web, Web 3. So this is basically blockchain. And before we understand Web 3 and all of that, let's quickly go through, or just like refresh in our mind what blockchain is and all of that, right? So a blockchain is essentially what you call as a distributed ledger technology, right? You've all seen physical ledgers in the past where records of transactions are being entered, and this is sort of a distributed ledger. And there is basically this whole concept of a growing list of records, and that's and each of those records are basically called as blocks, and every block stores a bunch of transactions, right? And there is a very interesting thing in a blockchain. Obviously, in the word blockchain, there's a thing called chain, right? So obviously there are blocks which are kind of associated with each other in a linked list sort of a fashion, and where every block not only stores a bunch of transactions, but also stores a cryptographic hash of the previous block and also a timestamp, right? So there is an interesting relation that way, and they have every block has a relation to its previous one, and so on, and they form a nice little chain, right? And one specialty that I wanted to call out is that this particular chain of blocks, right, it's stored on multiple nodes. The exact same blockchain is kind of stored on multiple computers, right, multiple nodes. And so there are different kinds of implementations of blockchains. You would have obviously heard of Bitcoin, and there has been so much of hype around Bitcoin. Bitcoin is an implementation of blockchain. Then there are things like Ethereum, Solana. So Solana is essentially what the second talk of the evening is going to be around. So that's also an implementation of blockchain technology. So this is just to familiarize, or just to remind all of us the terminology, basic terminology that is used in blockchain. Right? We have blocks, transactions, blockchain, cryptographic hash, which links to the previous block, and all of that. And of course, there are at least two kinds of blockchains. One is called a public blockchain, and the other is private blockchain. So a public blockchain is essentially where anyone, right, regardless of what your affiliation is, you are entitled, or you can participate in that public blockchain, right? There is no barrier for entry that way. So it's essentially permissionless, and there is no one centralized entity that controls the whole network. So anyone you me can read or write or participate within this whole network, and it's secure too, by the way. We'll discuss how it gets achieved in subsequent slides, but everyone, whoever participates in this blockchain, right, they are anonymous. So there is no real need to kind of use your name or identity. And that's basically what blockchain is about. So the public blockchain is about. So in private blockchain, as you can imagine, it's a permissioned sort of a blockchain. So there are a few entities that control the blockchain, and there is a reliance on a third party to provide that kind of a validation. Performance tends to be faster for a private blockchain, because obviously there are fewer blocks to maintain. In fact, fewer nodes to essentially maintain that ledger that we spoke about in the first slide. And some people say that it consumes far less power and energy, because a consensus is easier to achieve between all of those nodes. So that is again just a comparison of public and private blockchain. And let's now that we have set some context on blockchain, right, let's talk about this. What is Web3? So this is going to be a little bit of a detour to history, and we all know that so many people, several billions of people have all onboarded to the web, and what perhaps accelerated that is this so-called centralization, right? That kind of maybe lowered the barrier for entry, and so many people are plugged into the World Wide Web. But the only problem there is that it got monopolized by a few large corporations, and they get to decide what is allowed and what is not allowed. So as I was saying, let's quickly see how the history of web has been. So from this period of 1990 to 2004, so web was essentially you're just like sharing information through you have static pages, and there was hardly user interaction. User to user communication was not practiced to that extent in the Web 1 world. So this is that initial phase of what we call as Web 1, in that period of that decade, the late 1990s to the early 2000s. And there would be some content, some folks would publish content, but those are very small section of people, right? It's not like mostly it's a consumer driven thing. Like we all consume information, we go through articles. That was the case in Web 1, right? Now come Web 2, which was sometime around 2004, where you had all these platforms where users could exchange information, and there was user to user communication. Users could post information, and of course there could be consumption. So it was a very that way you might think of it as it was very collaborative and all of that. But the thing which we need to remember is that it was still controlled by a handful of corporations who control a lot of traffic, right? Overall, if you see the World Wide Web and take a portfolio assessment of what's the traffic that's happening overall, you would see that it's pretty much clustered on a few large MNCs, and they are essentially reaping a lot more disproportionate benefits when it compares to the the whole the billions of people who are actually plugged into World Web, the Web 2. So we don't own the content that we put out there, because any day the large corporation could just take away all that content. So it's all at the mercy of that large corporation, right? And we don't benefit enough from monetizing our own content. So that's when this whole realization happened, and in 2014, I think Gavin Wood, who's the Ethereum co-founder, he coined this whole premise of Web3, which is actually a solution for the problem that the Web2 world, it needed a lot more trust. So that's when this whole Web3, the idea of Web3 essentially came into picture, where we don't need to trust that handful of corporations, and we don't need to trust the fact that they'll do the right thing in the larger good for the public. So not as a finger pointing thing, but it's essentially how web has evolved, right? I think due to various reasons has evolved in a certain way, and a particular a correction had been identified, or a problem had been identified, and there are some technologies which are coming up to kind of solve that particular problem. And how can we get best of both worlds? So in a nutshell, right, like Web 1, if you think of it, it was read only. Web 2 was read write, and Web 3 will be like read write and own. Right? That's essentially how a particular tweet summarized this whole Web 1, Web 2, Web 3, and all of that. And at its core, so we initially started with blockchain, right? And you might be wondering what's the relation between Web 3 and blockchain. So Web 3 at its core, in its current the kind of implementations which are more widely known, blockchains are used under the hood. I'm not saying all of Web3 uses blockchain, but that's a predominant style that we have seen, architectural style we have seen, that Web3 has used cryptocurrencies, blockchains, and all of that to basically give that power back to users in the form of ownership. So yeah, so this is essentially what Web3 is. It uses cryptocurrencies, it uses blockchains, and decentralization, as I was talking about earlier, permissionless. That is, everyone has equal access to participate in Web3, and no one gets excluded that way, right? And there are native payments. You don't need to rely on some outdated infrastructure of some banks for your monetary transactions online. So you can use cryptocurrency for that. And there is this whole idea of being trustless. That is, there are no, you don't have to trust a third party to kind of do the right thing, right? So moving on, yeah. So Razin, you want to talk about this interesting thing of Web 5? We didn't talk about Web 4. We just directly jumped into Web 5.
Yeah. Where is Web 4? Web 4 completely skipped.
Yeah,
Directly.
I think I skipped that slide.
Okay, let's start with Web 5.0, and then we'll think about what is Web 3.0. So basically, the idea is that Web 3, where you want to own everything, but the current infrastructure, right? Most of the things are still in Web 2.0. And when Sir Tim Berners-Lee started the internet or World Wide Web in 1990, right? He has always imagined internet as decentral. And that did not happen because likes of Google, like Kumarji was saying, have started owning lots of stuff. So how easy is it today to move from those kind of a things where everything is owned by Google to something like a Web3? It's not, right. It's there will not be a right big jump. So what if we do a small jump? We create a architecture where some of the things are written in Web 3.0 and some of the things are written in Web 2.0. That architecture, Web 3 plus Web 2, the combination is called as Web 5.0. It's a term given by former Twitter CEO. The idea is very simple. I will develop few things in Web 3 and few things in Web 2, and we'll start an architecture that way. So what are the things which are pressing? And I should start with Web 3.0, right? Those are Those are some of the things which are mainly relying on trust. Basically, something which where you're having little lesser trust, you can start with those kind of use cases. Kumarji, can we go to the next slide? Yeah. So some of the use cases can be where you are having an identity, right? Where you are thinking that um, I I'm authorizing to some of the accounts like Google, right? You're doing a Google authentication, you're doing an Apple authentication. Should I give my data to everybody? Google, Apple, no, right? So that can be a really good start where you can probably start thinking about identity. But when we start thinking about that, right, the problem comes in with sometimes with blockchain, because blockchain, right, not everybody is really big fan of it. Kumarji mentioned in high level that it's Web3 is trending in blockchain, but not always true that everything should be in blockchain. So when we speak about Tim Berners-Lee's example, right, when he said that he wanted everything to be in decentral, did he really wanted to be things like identity, the example that I gave? Did he really want it to be in blockchain? No. So if he's not a very big fan of a blockchain, then this example of identity, where should I keep? Where should I keep the data? Or how do I do that? Can Web3 be working without a blockchain? That's a question that everybody asked him. And then he came up with his latest project called as Solid. If you search on Google, right, Tim Berners-Lee's latest project, you will go to the MIT research website where he's talking about a Solid project, where this kind of a data, right, identity kind of a data, and the word that Kumarji used, own, right, you own it. So you create a node which you own it, you store your own identity kind of a data, and then you use it you give an access of that node to anybody that you need, when you need, for how much time you need. So that's essentially a newer version of Web 3.0 without a blockchain. And if you still have your kind of a data like product API, right? Your list of products are still coming from your Web 2.0 and older APIs, then it is some of the part are Web 2.0 and some of the parts are Web 3.0. So that also suffices the definition of Web 5.0, which is given by former Twitter CEO. So this is how the things are combining, right? Web 3, Web 2, blockchain, not must, Tim Berners-Lee's latest project, and all these things are combining and probably moving us to the direction where some of the things ideally, I mean, the immediate next future, you should start thinking about some of the things in Web 3, some of the things in Web 2 by using features like Solid framework, by having identities or your data, your personalized data, PII data into things like pods in Solid, and you call it as Web 5.0. But yeah, next let's talk about what are the different use cases also that can go to Web 3. Because when we are talking about Web 5.0, we are saying that everything, we're not moving to the Web 3, right? What are the use cases which make sense? And we have wantedly put a money symbol here. What are the things which will help, right? So one I already spoke about. Identity is one of the good use case which Sir Tim Berners-Lee is talking about. But if we talk about the use cases, right now, the immediate future is people are thinking a lot around the trust area. So the example that I gave, right, identity, in that you don't want to give your data to everybody like Google, like Apple, like blah, blah, blah. You want to keep it with yourself. So trust is little less. But that is one example. But second example, where like, let's not talk about the data, but let's talk about one more example. We will keep coming to this example in one or two more slides. But an example of, let's say you want to play a lottery. So how it works, right? Lottery, you give your money. Likewise, let's say how many 57 participants are here. All 57 participants are giving $10 to somebody, and then so one of us are winning. So what we should get is, by let's say $10 is their fees, so $560 winner should get. But how do you trust? What if the lottery provider run away? You don't have a control on a centralized data, because lottery provider is storing on the data on their own, and then you don't know their APIs or code using which they are choosing the winner. You don't know, right, how they're choosing the winner. You don't know that. So those kind of a scenario, blockchain or Web3 is very, very helpful, where in Web3, right, you can see the contract or the API which are written, we will cover what is API. You can see that what is the code written, how it will be used. You can also trust that there is no centralized server, because everything in the blockchain or in the decentral way, using Solid or blockchain, everything is on a decentral way. So you can trust that, okay, winner will be chosen by somebody which is not an entity or human or something. Something like an Ethereum will choose, the machines will choose winner using cryptographics or something else. So there, right, you trust a lot. So lottery kind of a use cases are a really good use case to come here. In India, if most of you are from India, in India, we are going on to something called as ONDC, Open Network for Digital Commerce, where people can join that network as a courier provider, as a seller, as a buyer. So I'm having a Karyana shop. I can join ONDC as a seller. So I can just join that network that I want to sell these things. Then some courier provider will join. Then some buyer will join. Buyer will put something that I want to buy something. The best seller will be chosen by the chain of network. The seller will be, one of the seller is chosen. Then the seller will fulfill that network. Then courier provider will be chosen. That courier provider by network. That courier provider will come, take the order and go away. Right. So that's a future. In India, we are going to come up with that ONDC. That's not a blockchain. That's something similar to that or different to that, but that's not being advertised as blockchain, to be very frank. So those are some of the use cases where the Web3 really makes sense. Some more use cases can also be lying around openness, trust, and immutability. The advantages of blockchain, right? The immutability is also another example of a blockchain. There also those the Web3 is really helpful. So those are some of the use cases that we wanted to give you an example of Web 3.0. But yeah, we have spoken a lot about theory, right? Web 2, Web 3, Web 5, a lot about Web 5. But our talk is actually about journey for Web 2.0 to Web 3.0. So let's come back to the talk. Hand it over to you, Kumar.
Sure. Yeah, thanks, Razin. So what we thought is
Sorry,
Sure.
there is a raise hand by
Okay.
one. Yeah, it's
Is
by
that a
Manish.
Q&A
I
or
will.
is that
It's
Q&A
a
or
no,
raised
it's a
hand?
raise hand. Yeah,
All right.
let me unmute him. I think it's by mistake. I'm not seeing anymore. Yeah, Kumar, you can continue.
Thanks. Yeah. So I just want to maybe take that. I hope, because I think it's timely that there is a question on the Q&A. I'll just like answer it live before I move forward. And Avinash Sanji asks that Jack Dorsey's Web5 is still like a research project, and we are not sure if this will be coming to mainstream, and it's too early, isn't it? Yeah, I think the hype, the Web5 terminology might be like new one and a lot hyped. But still, I'd say there are architectures which are being developed. In recent times, very recently we spoke to someone from ThoughtWorks, and they had in fact used a hybrid approach, that a certain subset of their functionalities, wherever it came to trust, there were a bunch of corporations and they were not trusting. They didn't want that single source of truth, or rather a single entity which they want to entrust all their transactions with, right? This was the kind of project that they were working on, and that functionality was kind of nicely carved out into a Web3 architecture. Underlying that was blockchain. But then, of course, the rest of the app and all of that, there was still Web2 being freely used, right? So there is still merit in having a hybrid approach, and that way the idea of Web5 is still powerful. All right, I think Razin is also typing an answer, so I'll anyways move on with the next one, which is the Web3 from the lens of Web 2. So basically, we want to give you an idea on what it essentially takes to build Web3 applications. Given that we are used to architect applications in a predominant architectural style, you would have a database, you would have some APIs, you would have some invocation that is happening over the wire, you would have some infra that executes all of that code. So this is the usual thinking that we are all used to. So we'll just like break this into all of those 5-6 things, database and APIs and all of that, and then see what is the Web3 style of doing it. Right. Again, we might fall back on blockchain because, so although Razin mentioned that there are different ways of implementing Web3 and blockchain is perhaps the most pervasive one. So we'll still use blockchain as, as still that reference point, because that's the one, it's the most predominant and tangible way of implementing Web3. And also just so that you can draw more parallels, we'll take this To-Do app as a reference. You would have seen To-Do backend, To-Do frontend, various implementations of the To-Do app, which is essentially maintaining a list of to-dos, and how it is implemented in different web technologies and how it is implemented in different backend technologies. So similarly, we'll just think of the To-Do app, and in every slide, we'll also talk about how that To-Do would have been implemented if it were done in a Web3 style. All right, and going to database, right? So can essentially blockchain be used as a database? So blockchain under the hood, right? I think it is, you can kind of call it as a distributed database, and it is fully replicated as well. So, nodes store values, and those values can be changed only via transactions. I think that's the only catch over there. That is, there's a formal way of changing those values, and you can't simply go and mutate it like how update table set column equal to. So you can't do anything of that sort if you're from a Web2 world. But you can either add to the data or you can read from a blockchain. So that's essentially the concept of a database. And as I was saying, it's a fully replicated database, although there is this whole movement of sharding and all that will happen. Perhaps in Ethereum, I think that feature is going to come up in 2023. And right now it's essentially, fully distributed, and every node has, the entire copy of the blockchain. And volume of data, therefore, there's a limitation because, data is pretty much replicated across all nodes in a blockchain. And data integrity wise, right, you cannot tamper with the data because you might end up breaking the blockchain. So earlier I was mentioning that blocks are kind of related to previous blocks via a cryptographic hash, right? So if you tamper with the data on some transaction that happened in the middle of a blockchain, then you will essentially invalidate a lot of shards in that blockchain, right? So that means your node's copy of that blockchain will just go out of sync. Now, if you take a list of, if you take the To-Do app, right, you can kind of think of the fact that a list of to-dos will essentially be stored in all nodes of that blockchain. And there will be formal ways of adding to-dos to that list. You can't simply go and delete a to-do. So every mutation on that list will be captured as a separate operation. So there is no concept of, I can't go I can't random access into the list of to-dos and just change one of the to-dos, whatever value. So moving on to, so we spoke about a database, right? And I also mentioned that there is this way of interacting with the data, right? It has to be through formal ways, and which, in our Web 2 world, we'll call them as APIs, right? So the question is, what's the thing in Web 3 around APIs? What is it, right? And the answer to that is essentially this thing called smart contracts, right? So smart contract is essentially a program that you run on a blockchain. And it's now if you come from an OO background, you might remember the good old object-oriented principles of encapsulation, right? Where code and data are basically put in an umbrella. And that's pretty much the same thing as the implementation in blockchain, and that's what we call as smart contracts. So there is a state, and there are some methods that operate on that state, and they are all encompassed under one umbrella, and that is what you call as a smart contract, right? And smart contracts typically, they have, in addition to the state and the methods that operate on that state, of course they also have something like a balance, and they are often the target of transactions, right? Um, and this, smart contracts, they are deployed on the network and they run as programmed. A program is essentially a set of rules, and you define the rules in that smart contract, and they are automatically enforced. And users, they execute that function on the smart contract by invoking that function. Now, if you think of some popular implementations of blockchain like Ethereum, so Ethereum has Ethereum smart contracts, or smart contracts for the Ethereum platform are written in a programming language called Solidity. And Solidity is like, if you're familiar with a lot of curly brace languages, I think it's pretty much similar to that. They claim to, they are object oriented. That's an object oriented programming language. It is statically typed, and nothing changes from that aspect. And state should ideally be accessed only via smart contracts, and they should not be accessed directly. So we spoke about mostly, these are what we call as non-payable functions. Now in a to-do app, um, you have, earlier I spoke about like the list of to-dos being the data equivalent, or the database, or the data in the database is essentially a list of to-dos. So a smart contract would have methods like, say, add to do, wherein you will essentially mutate that, or you will add a new to do to that list of to dos. So that is your a smart contract function. And Razin, is there? I'm sure there is a lot more to smart contracts, right? Than just a to do getting added to a list of to dos. Is there something around payment and all of that? Maybe
Yeah.
you can talk about.
Yeah, so there are a few things here, right? What Kumarji have spoken about. So some of the things are inbuilt. Like if you take smart contract as an example of class, right? When you create a smart contract, you create a class and you create a methods and behaviors to that. You create a global variables to that. And there are certain inbuilt global variables. So every smart contract will have balance of its own, that how much money it is holding. Let's say a smart contract is created in Ethereum, then when it is deployed, right, it may hold some of the ethers, or some of the gas, or some kind of a money it can hold. Let's say it can also hold a zero money. And one of the behavior in the smart contract can be that add money or remove money, right? That can be also a behaviors in the smart contract. So money is an inbuilt concept in the smart contract. Everything else can be like a global variable concept, that you create a global variables, change those, um, and just access those, change those kind of a concepts will be there. So in case of to-do app, I mean, or in case, let's take an example of lottery, right? Basically, in case of lottery, all of us are giving money, but to whom, right? We spoke about the lottery example, to whom we are giving a money. So in this case, smart contracts balance will be increased. All 57 of us will be giving money to a smart contract. So let's say we're giving a $10 to a smart contract, then $570 will be a balance of smart contract. Then in smart contract, there are functions or behaviors which can be executed on an event. So let's say we're saying that event is 5 days later. Right, we're seeing that till 5 days we'll keep people adding money, and now on let's say 13th of September, early morning 9 a.m. we will be announcing an owner. So here we will create a trigger at 13th September 9 a.m. One of the behavior will be executed, that announce winner. Now what will happen in that behavior, right? You like any of the class, any of the classes behavior, this behavior will be called, method will be called announce winner. And in web 2.0 world, what we used to write, right? We used to write functions, methods, everything. The first line will be like you already have a balance 560. So first line would be take $10 and give it to the smart contract creator. Smart contract will also have an inbuilt variable called as owner. So take $10 and give it back to the owner. Then it will also have that there are 57 people joined. So there will be a global variable stored. How many people joined? 57. So it will say that out of 57, get out a random number between 1 and 57. Next line will be 0 to 57, get me a random number. The third line would be, let's say random number came as 3. So it will take out from array who is the user whose wallet is number 3. Take out that number 3. And for that person, transfer all $560. These are the 4 lines you can write in the smart contracts. Now there are some things to be known here. on the behavior when every line is there, right? Some of the lines are modifying global variables or payment. Some lines, those lines are called as transactions. Some lines are not modifying those. Like give me a random number between 0 to 57. Those are not modifying anything on either global variable like user added, money added. That's a global variable. Or give money to this person, take money from that person. Nothing like that. It's just give me a random number. So those lines are not called as transactions. Anything which is modifying the state of a blockchain in our language, the global variable or payment, those two are the state of a blockchain. If anything is verifying that, then that is called as transaction. If anything is not verifying that, then that is not called as transaction. In a single smart contract, single behavior, single method, you can have 10 transactions, 15 transactions. It's not like a one event has happened, then it is only one transaction. You can also have 10 transactions. All, let's say 15 lines are there. And like here, the GIF is showing when you want to transfer money from, let's say, Nancy to Albert, in that case also smart contract will be executed. That means Nancy will transfer money to a smart contract, it is funded. And it is also possible that when the smart contract is transferring money back to Albert, it might be failed. So if that is failed, now it is the responsibility of smart contract to give it back to Nancy. So this is also a responsibility of a smart contract. So while you are designing a smart contract, you need to also tackle the use cases like this. The Albert is, I'm not able to transfer money. I need to create another transaction that give back money from me to Nancy. These are the kind of things you should always take care while creating a smart contract. And then beauty of blockchain, like Kumarji have said, right? The blockchain is immutable. You cannot change it. So smart contracts are not as easily changeable as Web 2.0 APIs. So you need to be doing a lot of testing, trying to cover almost all scenario and then only deploy a smart contract, because once people start using that, they will start trusting that. And then when you create a newer version, it's not like API or a website that I hit facebook.com, there is a new version available, new version will come. People will manually have to start using new version, then only they will use new version. Otherwise, they wouldn't even realize. So you need to be very careful with the bugs. And transactions are charged. So you need to also be very careful of what you do and what you not do. So that's the thing. But yeah, one more really good concept here, right? Because we're talking about a journey for Web 2 developers and Web 3 developers. Like a Web 3 from the lens of Web 2 developers. In a Web 2, right, what we do is we have front end, we have back end, we have database. Now we have spoken about database, we have spoken about APIs, but there are two things, right? Two important concepts, right? APIs are normally called by front end applications, React application or a mobile app, whatever you want to call it as. And then APIs do call database. So here we covered database, we covered API. That equivalent of API is a smart contract, which is having methods. Database, one of the biggest thing that we did not cover here, I'll try to cover that in Web 2.0 world, right? When you connect database from API, there are concepts like those two are two different entities. There are concepts like you connect via network protocol, etc. Whereas here, right, it's very easy. Everything is given to you. For you, the database is your global variable, your class variable. Any public variable that you create, it's somewhat similar to database. You would have seen my LinkedIn post, right? I wrote in LinkedIn that what are we going to talk may not be 100% as it is, but it is very easy to understand. So here, right, I'm trying to explain you so that it is very easy to understand. If I have to connect something to a database, I don't need to create a schema. I don't need to connect it to something else called a database. I just need to create a public variable on that class. And then from any method I do access, that means I'm accessing database. So easy, very easy, right? Now, second thing, okay, I am able to connect database from my API just by accessing public variable. My API is methods in smart contract. But how do I access my API from a front end? Let's say I create a React app. In Web 2.0 world, I had a concept called as REST. I had libraries like Axios who were able to call on a REST protocol, which were also like HTTP. I mean, REST is, some people call it as protocol, but I don't. But yeah, HTTP2 on a HTTP2 protocol or HTTP3 protocol or HTTP1 protocol. On that,
you used to call an APIs, right? But how do you do that in Web 3.0 world, right? It's a smart contract. It's on the blockchain. I want to call one of the smart contracts. So I think here also, right, very similar to Axios, there are some libraries which are helping you. The internals are little difficult than HTTP1 or HTTP2. That how it is calling. I will also come back to the internal in the next slide. But for this slide, let's forget about internals. So there are libraries available similar to Axios. If you have to call it from React, the library is called as web3.js. There is a web3.js library in which you can say that I want to connect to Ethereum public network. Ethereum also has something called as dev network, test network. Test network is also there in Ethereum. So you can say I want to connect to test network, which is for a sample network where money will be fake, etc. And in test network, I want to execute contract ID1. In that, I mean, all those are methods in web3.js. So you can use web3.js if you have to connect it from JavaScript or from apps like React. If you want to connect it from mobile apps, in Android, there are Java libraries available for Ethereum. There is a library available from Ethereum from which directly you can call a smart contracts. And in Java, right, the toolchain is very, very good nowadays. The smart contract itself is a class and methods, right? So if you say that that to that library on a build time, your actually Java class equivalent to that will be generated. And when you just call that Java class and that method by passing the right argument on a network, that library will call the Web 3.0 smart contract. So this is how you can call smart contracts. But the question is, okay, I am able to call it from Java library. I am able to call it from my mobile app, or I'm able to call it from front end. But when I call it, Kumarji explained that blockchain is decentral. There is no server. And I am trying to explain that there are similarities. Then where is it, right? Because in the web API, in the Web 2.0 world, the APIs, when you call it, there was a concept of DNS. DNS used to find out the IP address. The IP address may be of something called as API gateway. From API gateway, we used to go to something called as load balancer. From load balancer, we used to go to maybe Kubernetes or maybe directly server. Let's simplify it directly to the server. But eventually, let's say out of 10 server, 15 server, one of the server was chosen and the code were executed. And those servers were owned by somebody who are owning the API, right? But here we are claiming no, Web 3.0 decentral. Nobody is owning it. And where does this code get executed? And then Kumarji also used the word, right? That blockchain is copied. All the blocks are copied to all the nodes. So let's say in Ethereum, there are 1 lakh nodes. Then all the nodes will have a definition of the same smart contract, every smart contract. So if I'm calling a smart contract, will it execute at 1 lakh time? That means get random number will be different for different people, then different winners on all the nodes, right? Then who will be the right winner? That's a problem, right? So it doesn't happen that way. It happens on a very, very similar way, the way load balancer kind of works. Basically, it goes to when you execute when you call a smart contract, right? It goes to the Ethereum network, and from Ethereum network, it tries to find one of the node where I want to execute this smart contract. Tanvi, Lahiri, and Kamli in their talk in the environment-friendly blockchain Solana, they will cover this in detail. But I'm just giving you a word that in Web 3.0 world, what is the word used, right? That word is called as proof of work. And the people who are coming next will be explaining you in detail what is proof of work. They will be doing with explaining it with a lens of Solana, but doesn't matter. In Ethereum also, the proof of work is similar. Basically, the proof of work is given to all nodes. One of the nodes figure it out that, okay, I want to execute this, and that particular node will execute that. Only one of the node, and that node is chosen randomly by Ethereum network. So this is how it works. Let's go to the next, right? We also explained about that while executing a smart contract, 1 or 2 things which can happen is a transaction, right? Now let's say the blockchain is open network, right? It's not like VMs owned by a single company. Like in case of let's say Google APIs, when you call, right, all the VMs are owned by Google. But here we are claiming it as decentralized. We are claiming that every one of us own the network, own the nodes. So what if I create a node and give it as a miner to Ethereum, and then I do a transaction? Hey, can you transfer 1 rupees from Kumarji's account to my account? And when it comes to my node, I say to a smart contract that, hey, give me 500 rupees. You are my smart contract, right? That can happen, right? Instead of 1 rupees, I'll just get a 500 rupees because node is owned by me. What if the transaction happens to my account? What if I just modify the smart contract in my account in my node that anybody's transaction giving money to anybody, out of which $0.1 transfer to me. Even that much will make me billionaire, right? I can just do those changes. I just need to have one node provided to Ethereum. So it doesn't work that way. Basically, even the claim is one of the node will be chosen to execute a smart contract. But like I said, in the smart contract, some lines can be a transaction. So whenever a transaction happens, that creates a new entry into the database, or in our language, new language now, it creates a new block in the blockchain, right? That's the thing. Now that block is created in all the nodes, and all the nodes verify that proof of work. That is it right? So let's say in case of the example of to-do app, or in case of example where somebody is winning the work, right? The to-do app, when we are doing, let's say I'm adding a new to-do work, or I'm modifying the to-do work, right? So I cannot just modify the task, or let's take a very simple example, right? I'm doing the operation is called as 5 minus 2 is equal to 3. And like deduct the money. I was having a balance of 5 rupees. The transaction is called as deduct 2 rupees from me. So the final result should be 3. But one of the contract can be hacked. So that will say that final result is 1. But all the other contracts will also try to execute the same proof of work and then try to find out the result. Is the result same or not? And if the result is same that is given by the executing node in more than 51% of a network, then only transaction will be called as verified. Otherwise, it will be rejected. So if it is same, and when somebody in some of the network, especially in private network, owns more than 50% of a nodes, then they can easily hack that particular network. It is called as 51% hacking. So it's also very famous. If you can Google it, right, you will get it very fast. So it's called as 51% hacking. It's a very good concept. But what I wanted to cover here is, in case of Web 2.0 world, your API is changing anything to the database, that means it is changed. But in Web 3.0 world, even if your API is changing something to a database, in our case, global variable, other people will also try to change the same thing, and they will verify is it a right change or not. And if it is verified, then it will be accessed. And that's why people claim that blockchain is much more secure. Because in Ethereum, you cannot have more than 50% of our nodes or verifiers or miners. That means it will be costlier than the money that you're earning, because it's very big. So that's why we call it as Ethereum is, the blockchain is little bit secure in the lenses of Web 2.0, but never ever think that Web 3 is always secure in the lens of Web 2, because Web 3 has their own different problems. With that, we'll go to the question and answers.
Yeah, sure. So just there's a time check also, which Kirti mentioned. So do we can we take questions on chat on the Q&A? How is it, Kirti?
Yeah, I think it's better we can take it in the Q&A session, because
Q&A.
we are running out of time.
Yeah, sure. All right. Awesome. Thank you so much for listening. So we have the next talk, right, coming up.
Yeah. Thank you, Kumarji. Thank you, Razin. It was very interesting and informative talk. So without much delay, let's quickly go to the next topic, which is about Solana. So we will be having the interesting talk about the Solana, which is one of the fastest growing blockchain platform. So we have Tanvi, Lahiri, and Kamala here. So over to you guys.
Yeah. Hello everyone. So I am Tanvi from Innovation Lab. So I work as SD in Innovation Lab. So I, along with my team members, Lahari and Kamli, who are also working as SD in Innovation Lab, will be presenting our experience and knowledge from a POC-based project that we did on Solana. So now that you folks are familiar with the fundamentals of blockchain, we'll dive into some nitty-gritty. The agenda for today is consensus mechanism, introduction to Solana, soul transfer demo, and ways to earn in crypto. So let us first talk about consensus mechanism. As we all know that blockchain is a distributed database, distributed across a network of nodes. All the nodes in the network will be having their own copy of database or ledger. Before any transaction starts and after any transaction ends, every node in the network should have identical copies of this ledger. Thus, if any transaction needs to be added to the ledger, it has to be appended by all the nodes in the network to their personal copy of the ledger. So every node will be acting as a gatekeeper for their ledger. So they'll be validating any transaction that needs to be appended to their ledger. Hence, it is required that all or at least majority of nodes on the network should validate and should approve of that particular block so that it can be added to the blockchain. And this is what is called as consensus. And the strategy which is used to bring about such a consensus in a distributed environment is called as consensus mechanism. Now, the goal of consensus mechanism is to prevent bad actors from adding the fraudulent transaction to the ledger. This mechanism relies on the assumption that 50% or more nodes in the network will be acting honestly and ethically. And in some of the consensus mechanisms, the nodes are also incentivized to act honestly and they'll be penalized otherwise. So consensus mechanism is actually encouraging ethical behavior and it will just safeguard the network. So we'll take a brief look at some of the very popular consensus mechanism, first of which will be proof of work. So when any transaction takes place, the transaction details are broadcasted to the network of miners. Now, miners are the people who will be adding these transactions to the new blocks. So they'll be validating the transaction and they'll be like picking up the transaction, creating a new block. So miners will be choosing which transaction they want in their blocks. Now, we all know about hash functions. These are the functions which accept any variable length string and produce a constant length output string, which is ideally unique. There are two main characteristics to any hash function, that is pre-image resistance. Given a hash value, one should not be able to compute back the input that generated that hash value. And the second characteristics is collision resistance. That is, two input strings shouldn't hash to the same value. So whenever a new block is to be added, so the miner is supposed to calculate a block hash. For a block to be mined, the miner needs to find an appropriate hash for the block. Now, generating just any hash for a set of Bitcoin transaction would be very trivial for modern computers. Thus, to convert this process into work, the Bitcoin network will be setting a certain level of difficulty to this work. This setting is adjusted so that the new block is mined, that is added to the blockchain by generating a valid hash approximately every 10 minutes. So a block will be generated and added to the blockchain every 10 minutes. Now, setting this difficulty is accomplished by establishing a target for the hash. The lower the target, the smaller will be the set of valid hashes and the harder it will be to generate that particular hash. In practice, this means that the hash will be starting with a very, very long strings of zeros. Now, usually hashes comprises of hexadecimal values. And if we look at a hash function of SHA-256, so given any hash input, it will be converting that input into a 256-bit output. Now, hexadecimal characters are 4-bit long. So if we divide 256 by 4, we will be having 64. That is, every hash for SHA-256 will be having 64 hexadecimal characters. So such is the hash. Now, since a particular set of data will generate only a single hash, then how will miners make sure to generate a hash that satisfy the given criteria? That is when the concept of nonce, that is the number used once, as it stands for, comes into picture. So the miners will be like finding this nonce. So there will be one such nonce after appending this nonce to the transaction data, it will generate a hash which will be satisfying this criteria. So the miners will be like iterating through multiple various nonces, and at some point, one nonce will be like satisfying the criteria, and that is when the block will be then broadcasted to the network. The network will then validate that particular block, and then the block will be added to the blockchain. So that was about proof of work. And this is not like the complete detail of proof of work. This is just like a brief look. And mostly we'll be considering some factors of proof of work, which will help us understand the further concepts, which are very much, related to Solana, that is proof of history. So we'll not be like taking a comprehensive look at them. So we'll also be discovering the second popular consensus mechanism, that is proof of stake. Proof of stake actually brings a revolutionary change to the process of selection of miners. And by the way, here in proof of stake, miners are called as validators. So to become a validator, one has to stake some amount of money or coins. So these people will be using their coins as collateral to become validators. Validators will then choose the transaction they want to include in their block. On Ethereum or Ethereum 2.0, 32 ETH need to be staked to become a validator. Thus, this protocol then will randomly select one of the validators to add a new block to the ledger. Then the block will be created by that particular chosen validator, and it will be broadcasted to the network. After validation, it will then be added to the blockchain. So now that we have seen how proof of stake and proof of work works, let us compare them. The first difference that we found is in terms of time and energy consumed. As we saw in the previous slide, that in proof of work, the miners were competing to find a particular nonce. That is why this competition causes a lot of time and resources to be consumed. That is why we can say that proof of work is very expensive in terms of time and energy. Whereas when we compare this same with proof of stake, we realize that in proof of stake, there's no competition. Rather, the validators have to stake their coins. So based upon the stake they have provided, the protocol will randomly select a validator. So we can see that proof of stake as compared to proof of work is very cheaper in terms of time and energy. So then let us look at another data point, that is the similarity between proof of stake and proof of work. And the similarity is the process of verification of time of events, or more precisely, the ordering of events, the process of ordering of events used by proof of stake and proof of work. Now, let's consider an example that right now I need some amount of money immediately. So one of my friends transfers me some money, and after that transfer occurs, I will withdraw that money. Now, in this situation, the exact time of transfer is irrelevant as long as the bank notes that the transfer occurred sometime before the withdrawal. Time is actually an abstract concept, and associating numbers or anything that is like easily interpretable to human brain to such abstract concept is a natural inclination. So from here, we conclude that order of events is actually the aspect which is of importance. Now, in proof of stake and proof of work, the order of events is achieved through communication between these validators or miners. This is required because every machine follows its own local clock, and there are bound to be differences in the local timings followed by these nodes on the network. That is why a communication between all of these validators have to take place so that they can come to an agreement over the ordering of events and like the time of occurrence of these events. And as you can see, as the number of miners will increase, so does the amount of time and energy consumed for this back and forth communication will. And this is the exact issue that proof of history tries to solve. So proof of history solves this problem actually pretty elegantly. And let us take a look at how it does. So to understand the further concepts better, let us consider consensus as two separate points. That is consensus over validity of transaction and consensus over the order of transactions. So consensus over validity usually takes place by validating the hashes of the transaction. And consensus over order takes place through back and forth communication, as we saw in the last slide. So thus majorly, there are three time-consuming aspects for any blockchain. First is the selection of miner, second is the consensus over validity, and last is consensus over the order of transaction. Now, proof of work consume time in all of these aspects. If we look at proof of stake, it consumed time in the later two, that is the whole consensus mechanism. And if we combine proof of stake and proof of history, time will be consumed only in the validation of transaction, thus reducing the time and energy consumed by manyfold. So let us see how that will be done. So generation of history. Now proof of stake uses a concept called VDF, or verifiable delay functions. These verifiable delay functions actually have really useful characteristics like slow and sequential computation, fast verification, and these are publicly verifiable and these are tunable. This function requires a sequential application of SHA-256 hashing algorithm. Output of the previous stage will be given as input to the next stage. This process can't be parallelized because there's a dependence on the output of the previous stage. So we can't parallelize this process and it will run sequentially only on a single core. And every stage of this process will generate two output. First is the hash value and the counter. Now, since this is a sequential process, reaching from one hash to another in this hash chain is a proof that actually some amount of time has been spent in calculating this hash. Thus, time can be approximated given two count values. As you can see, hash and count are the two outputs. So given two count values, we can approximate the time that has spent between these two. So let us see how we'll be using this VDF in ordering the data. So while calculating the hash, along with the previous hash, we can also input our data. Let's say our transaction data. We create a hash for this input data and combine it with the previous hash. The output hash computed will be very different from what would it have been had we not added the data. So basically, like if there's even like a small modification in the hash input, the hash output will certainly be very different. Thus, the output hash actually works like an upper bound of time for this data. That is, the data was generated sometime before this output hash was generated. This is because we need that particular data to compute this hash. So apparently the data existed before this output hash was generated. Well, we can have an analogy for this. Like analogy can be a photograph in a newspaper. So if a photograph is published in a newspaper, clearly it was taken before a newspaper was printed. So that's how the upper bound of the data, its upper bound for the time for the data is created. Similarly, we can also have the lower bound of time for the data. We create a hash of the data before it is used to compute the hash, as we have seen. So now we combine the previous hash with the data and then create the hash of the data. Thus now the hash for the data 2 includes the previous hash. So this is similar to taking a photograph with Times of India in your background. So apparently the photograph was taken after the edition of Times of India was published. So combining these two both concepts, we have an upper bound as well as the lower bound for our transaction data. And both of these upper bound and lower bound will then help us to, these will be like sufficient amount of data points for us to order the transaction. So that is how the history for the order of events is generated in proof of history. Now let us take a look at how verification will be done.
Hi, Tanvi. Sorry to cut you there. There is a raise hand by Renazir. Let me unmute him. Okay.
Yeah.
Hey, hi, Renazir. Are you able to talk? I hope I am pronouncing your name correctly. You are able to. You can unmute yourself and talk. Sorry, are you there?
Yeah, I can.
Yeah, go ahead.
No, let them continue. We'll talk about interoperability in the Q&A.
Okay, sure. I thought you had some doubts in the between. Yeah,
No, that
sorry.
was separately.
Okay, you. Yeah, Tanvi, you can go ahead.
Yeah. So while the history is being sequentially calculated, it actually can be verified parallelly. So if we have like 10 parallel resources, so we can actually verify 10 different hashes in the hash chain at one go. So that is why the validation is actually super fast. So in conclusion, we can say that inclusion of proof of history in consensus mechanism eliminates the need of back and forth communication among the nodes for ordering the events. Thus, it reduces the time and energy consumed by many folds. And popularly, it is said that proof of history is a consensus mechanism. But in my opinion, it is not a consensus mechanism, but more of a timing mechanism. Because we are using proof of history along with proof of stake to bring about this process. And proof of history like mainly focuses on ordering of events, which is like completely different topic as compared to consensus mechanism. So that was about proof of history. Now, there's a novel blockchain called Solana, which uses this type of consensus mechanism. And we'll know more about it from Larry. Over to you, Larry.
Thank you, Tanvi. So yeah, we already know some of the famous blockchains like Bitcoin and Ethereum, right? So Solana is also a decentralized blockchain, which is getting popular nowadays because of its step towards sustainability. So Solana actually uses hybrid consensus mechanism, that is proof of stake and proof of history together. So because of this, because of using proof of stake, there is no need of doing energy intensive mining that is harmful to the environment. And as well as to validate a transaction, there is no demand for energy. So because of these two things, Solana is trying to reduce the energy consumption a lot. And now we can see some statistics like, see, one Solana transaction actually consumes just only 1,837 joules, which is almost nearly equal to 2 Google searches. That's it. Whereas coming here, one Ethereum transaction consumes 690 million joules. That is very high. And when it comes to Bitcoin, it is like 6 billion joules. So now Ethereum is coming with a new blockchain, right? Ethereum 2.0. If for that Ethereum 2.0 also, it is able to reduce from 600 million joules to 126 joules, which is far more greater than what Solana is achieving, right? So by all these things, we can see that Solana is actually consuming a very less amount of energy for every transaction. So apart from this, Solana, because of its innovative features like parallel processing and proof of history, Solana is trying to achieve its Solana network in a secure and environmental efficient way. So actually, Solana people pledged to be carbon neutral throughout this 2022. And they're also coming out of their community and are trying to trying to fund for the permanent destruction of CFC and HFC refrigerants, which are 10,000 times more harmful to the environment. So that is why we can, by considering all of these things, we can see that Solana is taking a step towards sustainability. Apart from this, Solana is also trying to overcome some of the major disadvantages of existing blockchains, like cost of every transaction and the speed of every transaction. So when compared to other blockchains, the cost of every transaction in Solana is very low. And also the transaction speed, it is very high. Like it is giving 50,000 transactions per second speed in its network. So that is really high, right? So so Solana is not only giving us a step towards sustainability, but is also overcoming the major disadvantages. Like coming to the SOL token. So every blockchain will have its own native cryptocurrency. For Solana, it is the SOL token. So what is the use of this SOL token? This can be used in staking, and this can be used for paying transaction fees on Solana network. So what is this staking? We will be covering that in the next slides in a detailed manner. So coming to the account structure in Solana. So before that, I want to just introduce a small concept, smart contracts, which was already discussed before, but I would just want to mention it again. So smart contracts are simple programs that are stored on the blockchain and run when some predetermined conditions are met. So there is some change in terminology in Solana. Smart contracts are called programs in Solana, and these smart contracts help us, like they will just execute some random instructions. That's it. So, and one more thing in Solana is everything is treated as an account in Solana. So suppose say that you wrote some smart contract in Ethereum, okay? So then what would happen is the data and the code are coupled together in Ethereum smart contract. Whereas coming to Solana, the data and the code are separated. So the data in Solana is also stored in the form of accounts only. So that is why everything is an account in Solana, whether it is NFTs, wallets, or programs, everything is treated as accounts. So the programs in Solana, we can write them in Rust C and C++ languages. So these programs are special accounts. These are like somewhat different from the normal accounts. What is the difference? So these programs are actually treated, they are labeled as program accounts, and they are also having some Boolean variable executable, which will be S. So that is used to uniquely identify or differentiate between normal accounts and the program accounts. So yeah, as I have mentioned, the data and the code are decoupled in Solana. So what would happen here is, suppose you say that you have 100 inputs. Okay, now since the data and the code are decoupled, you can pass the 100 inputs parallelly. So the program will run 100 times parallelly. No need to write the same program many times, like 100 times. So that is how Solana people are achieving parallel programming. So yeah, that is one of the difference from the existing blockchains. Yes, coming to Solana Explorer and clusters. So as we have already said, like we already know, like a blockchain maintains transparency, auditability, everything, right? So how does Solana provide that to its users? There is something called Solana Explorer, where we can look up our transactions and accounts on various Solana clusters. So it will help us to just audit the transactions anytime and anywhere. So this Solana Explorer provides three main clusters, that is mainnet, testnet, and devnet. So what are these clusters and what do they do actually? These clusters just provide us the environment to deploy our programs or to create wallets or to create NFTs. So these clusters are just environments for us to develop something. Mainnet, this is the main cluster that is active all the time, and it deals with a real soul. Whereas coming to testnet and devnet clusters, these clusters mimics the functionality of the mainnet. They actually deal with the fake soul. That means not the real cryptocurrency, but the fake cryptocurrency. And these clusters help developers like us to experiment various projects on blockchain. See, you can't just do some experiments with the real cryptocurrencies, right? So that is why these clusters are provided for developers like us. And there is also something called localnet. We can't call this as a cluster. It is just similar to localhost. To this localnet also, we can deploy programs or create wallets or whatever we want, we can do it on this localnet as well. So yeah, coming to this creating wallet and airdrop. So today we just want to showcase how we can create wallet within just fraction of seconds and airdrop some soul into it within few seconds. As I have mentioned, Solana actually like performs 50,000 transactions per second, right? How fast can a blockchain do that? So we can just see the real example here. Before jumping into that, I just want to say, like, what is a wallet? Wallet is a unique pair of public and private key. Okay. So assume that you are having your real money. Where do you store it? You will store in your real wallets, right? Then where do you store your digital currencies and digital currencies or NFTs or whatever it might be, digital assets? You will be storing them in digital wallets. What's the importance of it? So they will protect our digital assets. Even if you want to send to someone, these digital assets will help us to send. If you want to send 1 Bitcoin to some other people, you can send from wallet to wallet. So that is the importance of wallet. And here there is some unique term, like unique pair of public and private key. Why the public key has to be unique? Because suppose see, you are having Instagram, right? So then your username Instagram is like unique. It is used to uniquely identify you on Instagram among several people, right? In the same way, your wallet will also have a unique public key, which will be used to uniquely identify you. And coming to private key, this is very important. This shouldn't be shared with anyone. If you lost it, then you lost your digital assets. That's it. Because once you have your private key, then the program or something will recognize that, okay, you are the real owner of it. And you already know everything in blockchain is like transactions, right? So to complete the transaction, you need your private key because you have to sign with your private key. That means you have to do digital signatures. So yeah, that is the importance of private key. Now today we will showcase you how we can create a wallet, like command line wallets using Solana. So it is just you have to install Solana libraries and all. Now I will try to show how we can create it in terminal. So I think it is visible to everyone. So yeah. So this is the command which is used to create a wallet in Solana. Now see, my wallet is created. It is this is the public key of my wallet, and the private and public key are stored here in this keypair.json. Now let's see this public key in the Solana Explorer. Yeah, so I created my wallet in DevNet cluster. As I have mentioned, the Solana Explorer provides 3 different clusters: mainnet, testnet, and DevNet. Now I have created my wallet in DevNet cluster. Now, if I see this public key, now you can see this is the account associated to my wallet, and the balance of it is 0 SOL. As I have mentioned, even a wallet is treated as account in Solana. So yeah, now I will do a simple thing. Now I will just transfer 2 SOL to that wallet. The command is very simple. Solana airdrop 2 and the public key of the wallet which I want to send, and I have to mention the cluster in which the wallet is created. Now you can see the transactions finalized, and that's it. You send 2 SOL to the wallet. Now let's check in the Explorer. You can see now the balance is 2 of this wallet. And you can even see the transaction signature. Just a minute. So this is the transaction signature associated with the transaction which I did. I airdropped 2 SOL to it. So that is how we can actually create wallets and airdrop SOL into those wallets. Yes, now coming to the demo of wallet to wallet SOL transfer. Today, we just want to showcase our knowledge, like how we have actually built a smart contract, deployed it, and then how we wrote a client so that it will trigger that smart contract. As I have mentioned, the program can be written in Rust or C++ languages, and the client can be written in command line interface or TypeScript, whatever it might be. So yeah, this is the smart contract which we wrote. What will this smart contract do is it will just transfer 1 SOL from one wallet to another wallet. So this is the thing which we wrote. We have written this smart contract in Rust language. Now, in order to build this smart contract, I will use this command. Now see, my smart contract is built. Now, in order to deploy this smart contract onto the blockchain, why do I have to deploy this? Because in order to be available to everyone, it should be deployed. Now I'm deploying this smart contract onto the DevNet cluster. Now, once I deploy it, I will get a unique program ID associated to that program which I had deployed. So let's see that. Yes, my program is now deployed onto the Solana's DevNet cluster. Now let's see this on the Solana Explorer. See, as I have mentioned, there is slight difference between a normal accounts and program accounts. the program accounts are labeled as program account, and there is a Boolean variable executable which is written as S. So this is how we can uniquely identify our program accounts on the Explorer. So now, since I had deployed, now I will use the deployed smart contract to run the client. Now I'm running the client and now see. So it is using the program which I had deployed to transfer one SOL from this wallet, that is 2MEK, to this wallet 6KP. Now let's see this wallet once. Yes, now you can see there is a transaction signature just a few seconds ago. This is the thing which we have did now. So now you can see from this wallet 2MEK, one SOL got transferred to this wallet 6KP using the program which I had deployed. So by using this program, it has executed these instructions which I said. So this is how we can build a smart contract, deploy it, and then use this. So as we have seen, like every transaction in the blockchain is like very fast. In this Solana blockchain is like very fast. So this can be one thing we can say is like Solana is the better way to like adapt Web3 to our lives nowadays. So yeah, now we will see the different ways to earn in crypto. Just a minute. Over to you, Kamali.
Yeah, thanks, Larry. So we saw different consensus mechanism and how it works and how Solana is more suitable for many things. And now let's see about different ways to earn in crypto. So like if you are new to this blockchain world, you would be most likely thinking that it is suitable only for developing crypto assets. But the real potential of the blockchain like extends beyond that as well. So as blockchain has progressed over the years, it is creating many avenues for the investors to earn a passive income. So like they don't know, though they don't need to wait and analyze analyze and tracking the performance of digital assets to make money. Instead, they can just earn rewards with their existing holding itself. So let's see some of the tokens first, which are circulating in the blockchain actually. Yeah, Larry, next slide, please. So fungible token and non-fungible token. So before seeing the definition of these two, what does a token means? A token is a visual representation of a fact. So in real life, we can consider that office ID card, which says that you're an employee of that particular company, or a driving license. It says that you have required all the trainings to drive in that particular company. In the country. Like that, token has a special value in this crypto space as well. So it can hold value, stakes, or voting rights, or anything. It simply represents that ownership of something unique for a particular user. So now let's see about different tokens available in this blockchain. And the one such thing would be the fungible token. So what fungibility refers to is the interchangeability with another asset for same value. So for example, we can take currencies. If say I'm having a 5 rupee coin, it is same as equal to another person having the 5 rupee coin. The value doesn't change. And if I'm having a 10 rupee note, it is the same as a person having two 5 rupee coins. And it is divisible as well. Like 10 rupee note can be divisible into 5 plus 5. And the values doesn't change even if you interchange. So that's how fungible token works. And these examples now I say like currencies or gold, those are like tangible ones, you can touch it. But when coming to intangible ones like Bitcoins or Ethereum, so those are in digital platforms which are intangibles. So now let's see about NFTs. So NFT serves as a unique token variant. Larry, previous slide. Yeah. NFT serves a unique token variant, like without any interchangeability with another asset. So for example, we can take CryptoKitties, which is one of the first most created NFTs in this blockchain world. So where if I want to send a CryptoKitty to another person and I am receiving another CryptoKitty, the one I sent and one I received will be totally different. And it is unique only. One NFT is unique and it is not divisible as well. We saw that in fungible tokens, coins and everything are divisible, but in NFTs, it is not the case. It is unique, and that that person holds the ownership of that NFT, and nobody can share that. So now let's see some of the examples of fungible tokens and non-fungible tokens. Yeah, next slide, Larry. Yeah, as we saw, like as I mentioned before, intangible ones, which are Bitcoin and Ethereum, which we can see in the digital platforms, and tangible ones, we can have an example of gold or currency, anything like that. When coming to NFTs, intangible ones, CryptoKitties or CryptoPunks or NBA shots, media files, anything can be created as an NFT. And when coming to tangible ones, we can take an example of a house or a property or a portrait, which has a unique representation, and the ownership is only you, and it can't be interchangeable as well. So let's see different ways how NFT works in an ecosystem. So yeah, ecosystem means it is a building blocks of nature, and we can consider NFT ecosystem as one such thing like that, but it is in online, where everything we accommodate, and we can trade NFT, we can exchange, we can earn in NFT, earn an NFT as well. So what combines an ecosystem? The first one would be the marketplace, where NFTs are being traded or exchanged, and even you can create one. And those NFTs can be sold to the in-chain currencies as well. For Bitcoins or Ethereums, you can exchange, like give that value and buy an NFTs. And the second one would be collectibles. So any form of physical or digital asset can be tokenized and become a collectibles. Like I mentioned before, CryptoKitties. So, or anything, if you are an creator or an artist, so you create an own asset, and that can be tokenized, and even that can be sold as an NFT. And then would be the gaming studios. So these NFTs based games providing ownership to increase the players' engagement and usage. There is a famous word called play to earn, where players come in and they can earn NFTs by playing the games. So that's the way they can get on digital pets, and they can sold that for in-game currency, and then can be traded for traditional currencies. So the next thing would be like NFTs and DeFi, so decentralized finance. So here, where you can get a loan for the like NFTs, you can get a collateral loan. But if the borrower can't repay the loan on agreed terms, then the NFT will be received to the owner, like the owner can have the NFT itself. And then the metaverse, like this is the most trending topics, because it is like more and more people are talking about this, because a marriage happened in metaverse, and movie trailer also released in metaverse. So what exactly this is? It is a digital platform where we just create our own avatars, and we can interact with like friends everywhere around the country. We can just go there and we can play, and we can also earn NFT in this metaverse also. So the land in metaverse can be owned, and that particular land says that it only belongs to you, and no one can hold the rights. And you can even do anything with that land. You can build any architecture or anything, or even you can lease out the land to any other players as well. That is possible, and you can earn through that as well. So these are the different things where NFT ecosystem combines together, and where you can earn, trade, and exchange other things. And next, we would see another example of earning in this blockchain, liquidity pool. So before diving into what is liquidity pool, we should know why we need liquidity pool. So we will just break into terms. So first, we will consider what is liquidity means. So liquidity means how easily and one asset can be transferred into another asset. So often fiat currencies. So one of such traditional way of exchanging is through order book model. So now let's see how an order book model works actually. So here we can see different sections for buyers and sellers. So the current market price of the asset will be displayed on this displayed on the chart, and buyers and sellers come together to place their orders. So buyers try to buy certain asset at lowest as possible, and sellers try to sell certain as highest as possible. So for trades to happen, both of them has to converge on price. So this will only happen when the buyer increase their bid and seller lowering the ask price. So that's when the consensus takes place and match will happen. So now let's see what are the drawbacks in this order book model. So time consuming for sellers. So what if the seller is in need of emergency, and the seller wants to sell some asset and wants to sell some asset in need of money emergency. So at that time, even if the buyers are there to buy that asset, there would be a lot of bargaining happening, because the consensus won't happen in a quick amount of time. A lot of bargaining would be happening, and then only at a fixed price they would land, and then only it can be sold. And then the possibilities of sellers being exploited. So in trades, traders or investors can encounter a difference between the expected price and the executed price, because price is not consistent here, and which is why the buyers and sellers has to compromise. And what if the sellers are in like in case of emergency to sell the assets, even if the price is not so good, the seller has to execute it, and he might get exploited as well. So the other disadvantage would be it is only appropriate for buy and sell. You are not lending your assets anymore. You are just directly giving the ownership of the assets, and it is only for buy or sell. It is not for lending purposes. So now let's see how liquidity pool overcomes these disadvantages. Yeah, next slide, Lily. So liquidity pool means a collection of tokens or digital assets stored in the smart contract. So liquidity pool has a minimum of 2 tokens, which creates market for that particular pool. So now let's see entities involved in this pool, like providers, users, and AMMs. So we will see one by one by seeing the working of liquidity pool. So we will see first by the liquidity provider. So provider comes into picture when the provider has to deposit the tokens, combination of assets, and creates the market for that particular token. For an example, we can take Ethereum coins and USDT. So the pool start with a ratio of 50-50, like the liquidity provider has to deposit 50% of Ethereum and 50% of USDT. It doesn't mean that the number of tokens should be the same. It means that the value of Ethereum and value of USDT should be the same. So like that is the purpose of liquidity provider here. Now let's see the entity user. So the user can swap tokens and they have to pay some fees. If say the user wants to exchange it for Ethereum and get back USDT, then the user can just swap the tokens and the user has to pay some trading fees as well. So here the sellers sell any asset that don't need to be a buyer at that particular time. Only liquidity need to be there in the pool. So the last one be the AMMs. So AMMs are protocols which use smart contracts. So they define the price of digital assets and provide liquidity. So on AMMs, like instead of trading against buyers or sellers, we are trading against the liquidity pool. So what is the benefit of liquidity provider? How the provider gets money out of it. So in exchange of providing their funds, we saw that user has to pay a transaction fee. So that a part of transaction fee would be going to the liquidity provider. So the rewards would be depending upon how much ownership the liquidity provider holds. There could be a lot of liquidity providers. It doesn't need to be one person. A lot of person can come in and invest there. So the ownership and how much the liquidity provider owns, the rewards would be based upon that. And the another one advantage is that here the liquidity provider is not selling his assets. It is just the liquidity provider is just lending the asset, and when the time the provider wants to take back it, just withdraw from the liquidity pool and get a reward from that. So this is how the liquidity pool works. Now let's see another use case, how to earn in staking pool as well. So this staking pool can be implemented in the blockchain which has POS concept. So we saw what is POS in the previous consensus mechanism. So the POS algorithm selects a validator for each block and they get rewarded when adding a new block. So how this staking pool comes into picture and how this works. So here a staking pool allows multiple stakeholders to combine their computational resource as a way to increase their chance of being rewarded. So they all together unite their staking power and say that I'm just selecting this validator and delegating this toll to this validator. So that validator has the highest chance of being selected and be able to add a new block so that the validator could be rewarded. And then a part of the reward would be given to the stakeholder, and how many stakeholders have delegated the soul to that particular validator, they would split among themselves. So this is the basic working of staking pool. And who are the entities involved? So the stake pool manager, and then staker, and then validator and stakeholder, that is the normal users. So how can a stakeholder stake their tokens? So 2 ways. They can directly put into the pool reserve or directly put into the stake account of the validator. Now let's see the operation of staking pool. So here a pool manager, the person who creates the pool and manages the pool, and then the stakeholder comes into picture whenever the person wants to stake his account, stake the delegate the stake to the validator. The stakeholder thinks that validator 2, I want to stake the amount. The stakeholder can just stake the amount to the validator 2. If the validator wins, how many stakeholders have delegated the stake to that particular validator, they would be getting rewarded, and the rewards would be splitted among the stakeholders as well. If the stakeholder is thinking that validator 2 is doing some malicious activities, the stakeholder has the power to rebalance the stake as well. Now, the stakeholder wants to rebalance the stake. Like the person don't want to put in validator 2, the person wants to put in validator 1. Person has the rights to delegate the stake to validator 1 as well. So this is the major scenario where the users as stakeholder can earn by some part of rewards, which is which the validator would be given. They from there we can split among the stakeholders. This is the one way of earning through the staking pool. So yeah, there are many other ways as well to earn in this field, like trading, yield farming, and mining. So the passive income in crypto is slowly gaining popularity as more and more investors are towards decentralization. And Solana is one of the many competitors in the world of decentralization, which has its own pros and cons, as it is common for every blockchains and everything. So Solana is also having its own pros and cons. In simple way, we can say that it is simply better for environment, which makes it more appealing for its users. And it is not only sustainable, but also gives us an opportunity to earn money by making transactions faster and cheaper. So in that note, I would like to conclude here. And yeah, any questions to take up?
Hi everyone, please feel free to post your questions in the Q&A session if you have any. And also a quick reminder that I have added the link for the feedback form in the chat. So please feel free to fill your valuable feedback to us. It's available in the chat, so please feel free to use that for your feedback. And I think we are good. We don't have any questions. Yeah, so thank you everyone. Thank you for joining us today for this event and for all the contributions and all the discussions and all. So it was very happy and thank you so much Kamala, Tanvi and Lahari for the wonderful talk. It was really informative and the hands-on experience was also really helpful. So really thank you. Okay. Yeah. Also, thank you for the session. And can I get the recording? Yeah, it will be. I think it will be. We will be sharing it with you. So thanks everyone again, and we will come back again with such a nice and wonderful topics. Thank you everyone, and please feel free to fill the feedback form. Yeah. Bye everyone.